You'll see a little scribble on top of the screen. That's because I started the video, didn't like what I was saying, so I'm going to restart and see what happens. Section 1.4 is on orders of operation, and generally most students are taught PEMDAS for orders of operations, which means if you're given an expression that needs simplifying, you simplify parentheses first, exponent second, multiplication and division. The M is multiplication, the D is division, and A is addition, S is subtraction. This is generally the order that we're told to simplify problems with. Sometimes I like to just think PEDMOS because it turns out that it doesn't matter. Well, it does matter. That it turns out that you're allowed to do division before multiplication if it occurs further left, and probably should even did pedum saw, would even be better. And you could do subtraction before addition. So when I'm simplifying an expression, I look for parentheses first, and I do all the operations inside of parentheses. Parentheses can be round parentheses, they could be square brackets, they could be curly set braces, and absolute values will also count as parentheses. So when I say simplify a parentheses, this means if there's a parentheses that has an operation inside, parentheses, round parentheses, square brackets, squiggly brackets, or absolute values, I'll get any parentheses in a problem down to a single number. And then after parentheses, I'll work on exponents. After I've gotten all the parentheses down to a single number, gotten rid of all the exponents, then I'll look for division and multiplication and work those from left to right. I can do division before multiplication if it occurs further left, or I can do multiplication before division. It just depends how the problem was written. Similarly, for subtraction and addition, which is the last part of orders of operations, once I've gotten rid of all the parentheses, all the exponents, there's no longer any division or multiplication, then I start doing subtraction and addition, and I work from left to right. If the subtraction occurs further left than the addition, you do subtraction before addition. There's one evil trick in this section that has to do with exponents. It's kind of an orders of operations, maybe not really. It comes up a few times in our class, comes up in college algebra, comes up in calculus, and this is exponent simplifying. If I looked at this compared to this, I read the opposite of 8 squared. This I read as negative 8 squared. So this first scribble that I wrote, this is the opposite of 8 squared, whereas this is negative 8 squared. In the first scribble that I have, I'm going to square the 8 and then find its opposite. So in this first one, negative 8 squared, I'm going to figure out what 8 squared is, and exponents, when they're positive integers, are just repeated multiplication. So I'm going to find 8 squared, which is going to be 8 times 8, which is 64. And then I'm going to find the opposite of 64, which is negative 64. If there's a negative sign preceding a number and that negative sign isn't in a parentheses, you do the exponent first, find the opposite, or just make the answer negative. If the negative's inside a parentheses, then when I'm simplifying to get rid of that exponent, I'm actually going to change the exponent to repeated multiplication. And now negative 8 times negative 8 is positive 64. If I was going to write this first example all in a nice string, I would say this is the opposite of 8 times 8 because I'm squaring the 8 and then finding the opposite. So it's going to be the opposite of 64. The first chunk of problems I have in this section are just beating this trick to death. And then the rest of the problems are orders of operations. And I'll skip my examples because we're going to do so many examples in the section that this will just make the video longer than it needs to be. Super have to be careful. When I wrote up my keys to this section, I just mindlessly press buttons on my calculator, and for some reason, my calculator and many calculators aren't programmed perfectly, and sometimes they give a wrong answer to complex orders of operations problems. I know sometimes on Facebook, I'll see somebody post, what is this equal to? And it's an orders of operations problem, and people will debate what it equals to, and sometimes my calculator will lose that debate because it gives me the wrong answer. So I'll be super careful to do everything by hand in this section. 99 times out of 100, my calculator will give me the right answer. Or maybe say there's 64 problems in this section, and I think I got 3 wrong by just pressing buttons on my calculator. So maybe even 1 in 20, my calculator might not quite get right. So first few problems are just beating to death this exponents with negatives, either if it's finding the opposite or if it's actually, raising that number to a power. So number 2 wants me to find the opposite of 3 squared. So 2a, I'm going to say this is equal to negative the opposite of 3 squared. And 3 squared is 3 times 3. The answer to 2a is going to be negative 9. I'm going to square the 3 and then get 9 and find its opposite. Whereas 2b actually wants me to square negative 3. And to square negative 3, I'm going to multiply negative 3 times negative 3. When I multiply 2 negatives, I get a positive. Every single problem on this page has exactly the same trick. Some of the answers will be the same number, and some of the answers will be opposites. It has to do with if the exponent is even or odd. 4a, because the negative isn't in the parentheses, 4a wants me to find the opposite of 3 to the 4th. So I'm going to find 3 to the 4th, and then I'll find the opposite of it. 3 to the 4th is 3 times 3 times 3 times 3, and I like to keep the number small, but maybe that's a little big. 3 to the 4th is 81, and the answer to 4a is going to be negative 81. For 4b, because the negative's in the parentheses, this actually wants me to find negative 3 to the 4th power. It wants me to multiply negative 3 by itself 4 times. When I have a string of multiplication, I count the number of negatives. If there's an even number of negatives, the result of the multiplication is positive. If there's an odd number of negatives, the result of the multiplication is negative. And here, there's 1, 2, 3, 4 negatives. 4 is an even number, so this is going to be positive. If there were 3 negatives or 5 negatives, an odd number of negatives in a string of multiplication, you get a negative. But an even number of negatives gives me a positive. I'll show you these on my calculator real quickly because my calculator does fine. So I'm going to do negative, or the opposite of 3 exponent 4. And that gives me the negative 81. That's the opposite of 3 to the 4th. In the part B, negative 3 inside using these parentheses, exponent 4 is going to give me the positive 81. Let me autofocus again. I don't like this focus. 6 I think is believable to do without a lot of knowledge, but maybe 8 isn't. 6a wants me to find the opposite of 3 cubed. So I'm going to figure out 3 cubed by multiplying 3 times 3 times 3 and then make it negative. 3 cubed, 3 times 3 times 3 is 27, and the opposite of positive 27 is negative 27. The answer to 6a is negative 27. 6b wants me to cube negative 3, which is negative 3 times negative 3 times negative 3. Here there's 1, 2, 3 negatives. If there's an odd number of negatives, the product is negative. If there's an even number of negatives, the product is positive. Since there's 3 negatives and 3 is an odd number, the product's going to be negative. And then 3 times 3 times 3 is 27. That's about as big as I'd make exponents on a test. I don't probably make them as big as they're going to be in problem 8. But both of those answers are negative 27. That has to do with the exponent being odd or even. If the exponent is even, these will produce answers that are opposites. If the exponents are odd, the answers will be the same. Lastly, 8's a little bit silly. 8a wants me to find the opposite of 3 to the 5th, which means I need to figure out what 3 to the 5th is. That's multiplying 3 by itself 5 times. Wouldn't do that on a test. 3 to the 5th is 243, and I want the opposite of 243. So my answer is going to be for 8A, negative 243. 8B wants me to multiply negative 3 by itself 5 times. I know the answer is going to be negative because there's 5 negative numbers. I count up the number of negatives. Here there were 4 negatives, even number of negatives, it's positive. Here there were 3 negatives, odd number of negatives, it's negative. Here, there should be a 3 there. There are 5 negatives, 5's an odd number, so this is going to multiply out to be a negative, and 5 3's multiply out to be 243. So that trick will come up occasionally. It's a super common trick. No matter how high you get in an algebra class, you're going to constantly see that trick. The rest of the problems are just straight orders of operations, and I have to know what to do first, second, third, and fourth. For problems 9 and 10, I look at these. There isn't a parentheses. I'm not going to worry about a parentheses in problem 9 nor in problem 10. There isn't an exponent in problem 9 or problem 10, so I won't worry about it either. Then I look for division and multiplication. In problem 10, there's multiplication. That needs to be done first in this problem. So I'm going to bring down the 4 and the minus, and I'm going to multiply the 3 and 6 and get 18. So there wasn't a parentheses, there wasn't an exponent, there wasn't a division. I did the multiplication, and then I look for subtraction and addition. This is a subtraction. I can do this without making it addition, but if you can't, 4 minus 18 is the same as 4 plus negative 18. Those numbers have opposite signs, so I subtract and take the sign of the larger. So I'm going to go 18 minus 4 is going to be 14. Because the bigger number 18 is negative, the result is going to be negative. So you should give number 9 a go. And I'll work on number 12 next. On number 12, I look, there's no parentheses. Don't worry about it. There's no exponents. Don't worry about those. There is division and there isn't multiplication. I'll do the division first. So first thing in number 12 is to do the 20 divided by 5. I'm leaving the minus sign out front. I'm just working on 20 divided by 5, which is 4. Done with the division. And then I have to worry about subtraction and addition. There's only subtraction left. I don't have to worry about the addition. And 12 minus 4 is going to give me 8. So my answer to 12 is going to be 8. Um, 13 and 14 are similar. 13 and 14, if I work on 14, there's no parentheses, there's no exponent, but there's both division and multiplication. When there's both division and multiplication, you don't do the times first if it's not written first. You do whichever of the two is written first. So the first step in problem 14 is going to be to do the division because the division sign is left of the times sign. I'm going to leave the 20, I'm going to leave the minus, I'm going to leave the times 6 and the plus 3, and then I'm just going to do 24 divided by 8, and I could do that in my head and I get 3. So I'm done with the division. Now I look at this problem, there's no parentheses, there's no exponent, there's no division, but there is multiplication. I need to do the multiplication before any subtraction or addition. So I'm going to leave the 20, I'm going to leave the minus, I'm going to leave the plus 3. Now this 3 times 6 is going to give me an 18. So now I've gotten rid of all the division and the multiplication. Now I'm going to work left to right. I don't do addition before subtraction if it's second. So in this problem, addition and subtraction are the only operations that are left. And I'm going to go in order, left to right. I can do subtraction before addition. 20 minus 18 is 2. And then I'm just left with the one operation, 2 plus 3. My answer to 14 should be 5. Your problem 13 should work exactly the same. It's structurally the same, just I put different numbers in. Try to pair the problems up like that for all of these. If I look at 16, there's no parentheses, so I won't worry about it. But in 16, I have to worry about exponents, and the exponent is 3 squared. Needs to be done first. 3 squared is just 3 times 3, which is 9. So I'm going to leave most of the problem intact. I'm going to leave the 4 plus 36 and divided by, and I'm going to change the 3 squared to 9. Done with the no parentheses, I'm done with those by default. Done with the exponents. Now I look for division and multiplication. There's only division, I'll do it next. 36 divided by 9 is 4. I'm going to bring down the 4 in the plus sign. I'll do the 36 divided by 9 and get 4. So I'm done with my division. There is no multiplication. And then for subtraction and addition, well, there's only addition left, so I don't have to worry about subtraction. I'll just do the addition, and I'll get 8 for an answer for 16. On the next page, problem 18 has a parentheses. So the very first step in number 18 is I'm going to work on the parentheses. I'm going to get the parentheses down to a single number. So it's going to be 5 minus 3, and now the parentheses is going to turn to a 5. Done with the first step. No parentheses left other than the parentheses I wrote. But by parentheses, I mean a parentheses that has more than one number inside. Next, I would do exponents, but there's not an exponent, so I'll slice that out and say I don't need to worry about those. And then it would be division or multiplication. Since there isn't any division, I'll default to the multiplication. I'm going to multiply the 3 and the 5. I'm going to bring down the 5, and I'm going to bring down the minus, and then 3 times 5 is 15. Done with the multiplication. Now it's either subtraction or addition. And these are equal. 5 minus 15 is the same as 5 plus negative 15. I don't have to rewrite the subtraction as addition to know how to subtract. For me, 5 minus 15 is just negative 10. So my answer for number 18 should be negative 10. 20, my answer is large. When I go to do 20, first I'm going to do the inside of the parentheses. Inside the parentheses on number 20 is minus 1, minus 7. If I need to, I can think of that as minus 1 plus negative 7. Subtracting a positive is the same as adding a negative. Regardless of how you need to think of this, both the signs are negative, and when that's the case, you add the numbers and keep them negative. First step in problem 20 is the parentheses, to get that parentheses down to a single number. I'm not dropping the parentheses when I get it down to a single number, but nevertheless, I needed to get the parentheses down to a single number. So parentheses done. Now it's exponents, and this exponent needs to be done in the negatives in the parentheses. So when I do this exponent, the negative 8 squared part of this problem, it's one of the kind of part B's. It's going to be negative 8 times negative 8, which is going to be 64. So done with parentheses, done with exponents. There isn't any addition or subtraction to worry about. The next step would be division and multiplication. There isn't any division, so I need to worry about multiplication. I'll keep the numbers small on the test. If I don't let you use a calculator, I wouldn't make you do that multiplication. I don't care to do it. Now I've got this down to one number, so I'm going to just call that my answer. I have a key out here that I'm checking to make sure I'm not making a mistake, even though I found some errors on my key recently when I checked the odd problems because I didn't do these by hand. Let's do 22 together. What the heck? So in 22, there isn't, or 21, there's no parentheses, there's no exponents. There is division and there is multiplication. When there's both division and multiplication, you need to work from left to right. So the first step in problem 21 is to do the division of 24 divided by 6. 24 divided by 6 is 4. So there's no division left, but there is still multiplication. My second step for 21 is to do the multiplication. of 4 times 3, and 4 times 3 is 12. Done with the division and multiplication. Now I'm on to the subtraction and addition. There isn't any subtraction, so I'm just going to do the addition. I'm going to work from left to right. First I'll do 2 plus 4 is 6. And then I'll do 6 plus 12. And my answer to 21 should be 18. I don't like the size of the numbers, but I think it's going to come out nice for both of these. Let's do 23 together. I'm just afraid that I wrote something that the numbers are so big that it's going to overwhelm me if you don't have a calculator. So if I was doing 23 and not 24, if I was doing 23, you should pause the video and try it. If I was doing problem 23, the first thing I need to do is get the parentheses down to a single number, because parentheses is first. And inside the parentheses, I need to do the multiplication of 3 times 8 before the addition, because you do multiplication before addition. And then after you do the multiplication, you'll do the addition. So if I was writing problem 23 down for my second line, what I'm going to do is simplify the parentheses down to a single number by multiplying 3 times 8 and getting 24 and adding 6 and getting 30. So technically I'm done with parentheses. Even though I have a parentheses left in my work, it's not an important parentheses because it's just a single number. There isn't an exponent. There is division, but there isn't multiplication. So I need to do this division of 900 divided by 300, by 30 should I say. And it might help me if I write that as a fraction. We haven't got into reducing fractions just yet, but this is an easy one because I can hack out the zeros and make this 90 over 3, and 90 divided by 3 is 30. So my next line I'm going to write is 30 and bring down the minus 10, and then I look for subtraction and addition. There's only the subtraction left, so I'm just going to subtract 30 minus 10 and get for 23 an answer of 20. I'm going to do 26. I'm worried again about the size of the numbers in 25, but I'll let you struggle with those. Let me do 26 so I don't steal all of your even odd problems. So first thing in 26 is this parentheses. I want to get it down to a single number. The parentheses in 26 is 14 divided by 7 times 7. I need to do the division first. It has both division and multiplication, and if division is further left, I do left to right. So 14 divided by 7 is 2. Bring down the times 7, and 2 times 7 is 14. I'm going to leave the 14 in a parentheses, but I probably don't really need it in a parentheses. Maybe even almost looks silly to have it, but it's going to be 52 minus, I don't know why I wrote that parentheses, but I did. I don't need that parentheses, it's not necessary, but it's there. So I've done the parentheses part of this. Inside the parentheses, I did the addition, the multiplication and division. And now I just have straight subtraction, so I'm going to work from left to right. First, I'm going to do 52 minus 14, which I can do in my head. Outside of the first test, you can use a calculator for any subtractions, multiplications, any algebra that you can't do in your head. And now I'm going to do 38 minus 23, and my answer for 26 should be 15. I hope your answer for 25 isn't disgusting to get. I have an answer of 906 written down for 25. I think that's because this whole part right here comes out to 16. You go 900 plus 16 minus 10. I don't think the problem is ridiculous to get, even though the answer is a big answer. I think I'm going to pause and make a part 2. Let me do this sheet and then I'll make a part 2. On 28, I see double parentheses. The second parentheses wouldn't get done first because they only have single numbers inside. So in 28, parentheses first. Parentheses that have operations inside, not just single number parentheses that are just holding their place. And then exponents. 3 squared is 3 times 3, which is 9. So I did parentheses, exponents. Now I'm into the multiplication division part of this. I need to do that multiplication first. 3 times 5 is 15. And then the addition, 9 plus 15 is 24. My answer for 28 should be 24. 30 is similar. I have a parentheses in it. I'm going to do the parentheses first, get it down to a single number. Those parentheses don't count as the parentheses simplification because they're just single numbers. So first step, 6 plus 4 inside that parentheses, get it down to a single number, is going to be 10. And then I'm going to do the exponent of 10 squared. 10 squared is 10 times 10, and that's going to be 100. Now I'm in a problem that has both division and multiplication. I go from left to right. First I'm going to do the division of 100 divided by 5. If I can't do that, I'll keep the numbers small on a test. 100 divided by 5 is 20. So that's going to turn into 20. I still have the times 5. The answer to this should be 100. And if you saw my key, you'd see there's a mistake because my calculator, it's not programmed perfectly for all orders of operations. Every now and then if I enter something on my calculator, what my calculator did is it multiplied the 5 and the 5 first. It did multiplication before division. That's not right. So flaw in the programming. 32, I'm going to start doing the parentheses of 3 minus 4. Get rid of it first. And 3 minus 4 is the same as 3 plus negative 4. Those numbers have opposite signs. You subtract the 4 and 3 and get 1 and make it negative because the larger number is negative. So first step. Parentheses, done. Got the parentheses down to a single number. Now I'm going to work on the exponent. The exponent is negative 1 squared. Because the negative's inside of parentheses, I multiply negative 1 times negative 1 to clear the parentheses. So this is going to be 20 divided by 5. Exponent gone when I turn that to a 1. And now it's either division or multiplication. I'm going to do this division. 20 divided by 5 is 4. And lastly, all I have is addition. And once I get down to two numbers, I know how to combine them. I'm just going to combine them properly. So for 32, my answer should be 5. 34, first I'm going to do the parentheses. The parentheses is negative 6 minus 1. If I need to, this is the same as negative 6 plus negative 1. Minus a positive is the same as plus a negative. Regardless, I have two negative signs. I add the numbers and keep them negative. The parentheses is going to simplify to negative 7. That's the first step for my orders of operations. So it's going to be 5 plus 3 parentheses negative 7. Got all my parentheses simplified as much as I need to. There isn't an exponent. I won't worry about it. There's multiplication but not division. I need to do the multiplication next. 3 times negative 7 is negative 21. And now I'm in the addition subtraction, and I don't have subtraction, I have addition. When you're adding and the numbers have different signs, you subtract and take the sign of the larger. So I'm going to go 21 minus 5 is 16. The bigger number is negative, so I'm going to make it negative. My answer for 34 should be negative 16. When we have fractions, we kind of consider the numerator and the denominator separate, kind of inside parentheses. Even though there's not parentheses, the fraction bar makes it so I'm going to simplify the numerator separately from the denominator. So when I go to do problem 36, separately, I'm going to figure out what the number the numerator simplifies to by doing orders of operations for it. And separately, I'm going to figure out what the denominator equals to by doing orders of operations on it, completely separate from each other. So in the numerator, there's no parentheses, There's no exponent. There is division. I need to do the division first. The numerator is going to be 14 plus 2 because the 6 divided by 3 is 2. The numerator of this fraction is going to simplify to 16. So when I go to reduce this, I do the numerator and the denominator, get them separately down to a single number, and then I'll reduce the fraction. In the denominator, I have a double negative. It's not really of orders of operations. It's just make the double negative positive. The denominator is going to be -5 plus 3. There isn't a parentheses with an operation inside. There isn't an exponent in the denominator. There isn't an addition or there isn't an exponent. There isn't a multiplication or a division. The denominator, when I make the double negative positive, I get -5 plus 3. I'm going to go 5 minus 3 and get 2 and make that negative. So the denominator comes out to -2. So in 36, I'm left with 16 over -2. And 16 over -2 is going to be -8. So my answer for 36, 14 plus 2 is 16. -5 plus 3 is 2. Let me do this on my calculator. I have a different answer written down. I don't think my calculator should mess this up. 14 plus 6 divided by 3 over -5 minus -3. Yeah, -8 feels good for an answer. So I'm going to pause and do a part 2. It's a little bit longer than I want the videos to go, but it kind of is what it is.